Hello everyone, I am Adithya Kashyap and I am going to talk about introduction to measurement systems. So here instrumentation is a branch of engineering which deals with measurement and control of physical quantities. Now when we come to the basic terms, here we have two terms, measurement and control. So measurement, if we have to define, we can define measurement as it is an act or result of comparison between an unknown quantity and a predefined standard. So let us take an example. When we go to a vegetable market and buy, for example, 2 kgs of potatoes, what will the vendor do? He will take a 2 kg bar, put on one side of the balance, and at the other side he will place the potatoes until the needle comes to the middle position. So what is he doing here? He is trying to compare an unknown quantity with a predefined standard, that is the 2 kg bar. But every measurement has to be followed by a unit which defines the physical quantity being measured, or it becomes a meaningless quantity. So, thus, we can define measurement as an act or result of comparison between an unknown quantity and a predefined standard, which is always followed by a unit which defines the quantity being measured. So here measurement is again of two types, direct measurement and indirect measurement. In case of direct measurement, we follow the definition what we have talked about just now. So that is we compare the unknown physical quantity with the predefined standard. But in indirect measurement, let us take an example. I want to measure current in a circuit, but I have voltmeter. So by using voltmeter also I can measure current, that is by using Ohm's law. That is, since I know Ohm's law V is equal to IR. So I try to measure voltage using the voltmeter, and then using Ohm's law I will try to measure the current. So this is indirect type of measurement. So thus measurement is of two types, direct and indirect. And in order to perform some measurement, we need an instrument, that is a device. So the device used to perform measurement is called an instrument. So if we try to understand what does an instrument contain, here is the block diagram of the instrument. So the physical quantity which is to be measured is first given to the instrument. So the instrument consists of three stages: one input stage, next an intermediate stage, then a output stage. So at the input stage you have some transducer which converts one form of energy into another form. Then at the intermediate stage, you will have some processing elements and an instrumentation amplifier. And at the output stage, you will have a indicating instrument. So at the instrument, if I talk about, it consists of three stages. The input state consists of a sensor or a transducer. The intermediate stage consists of a signal processing unit, and the output stage consists of an indicator. Now, if I want to do some complex measurements, then the measurement system comes into picture. That is, for complex measurements, different subsystems have to be embedded together, which forms a measurement system. Now, here is a block diagram of a measurement system. So, the quantity to be measured is given to a measurement system, which generally consists of 5 blocks. Not guarantee that we need all these 5 blocks together, but generally we have this 5 blocks. The first block is a primary sensing element, then second block is a variable conversion element, the third block is a variable manipulation element, the fourth block is a data transmission element, and the fifth block is a data presentation element. So now let us take a simple example of a Bourdon tube which is used to measure pressure. So this is the construction of a board on tube, where you have a tube and the end of the tube is connected to some mechanical measure system, such that the input pressure is indicated on a pointer on a scale arrangement. There is pointer and scale arrangement. Now, if I take this example, the primary sensing element is the board on tube, and also the variable conversion element also can be considered as this tube, because the tip of the tube deflection means it is converting the input pressure into output displacement. Then comes to the variable manipulation element. The mechanical linkages here will constitute the variable manipulation element and data transmission element. That is, for example, the gear mechanism here will constitute the variable manipulation element, and the mechanical linkages will constitute the data transmission element. And the final data presentation element is the pointer and scale arrangement. So this is a simple instrument which is used to measure pressure, and this instrument consists of all these five elements: primary sensing element, that is the board on tube; variable conversion element, also the board on tube; variable manipulation element, the gear mechanism; data presentation element, the mechanical linkage; and the data presentation element, the pointer and scale assembly. Next, if we want to define two terms which are very important, that are sensor and transducer. So a sensor is a device which converts one form of energy into another form. Sensor is a device which converts one form of energy into another form. Whereas transducer also goes with the same meaning. But here, as the many textbooks go with the same meaning, as I told, here sensor is a device which senses a physical quantity and produces some output, whereas transducer is a device which converts one form of energy into another form. That means sensor only senses the physical quantity and produces output, whereas transducer converts it into another form. Majority of the transducers what we are using today are electrical transducers. So if I define an electrical transducer is a device which converts one form of energy into electrical form. So why we are using electrical transducers as such? So there are some advantages of the electrical transducers. That is, electrical amplification and attenuation can be easily done, and as we are not using any mechanical elements, we don't have mass inertia and frictional effects. The third point is the output signal magnitude can be related in terms of voltage and current, and it can also be controlled with small power levels. And finally, the electrical output can be easily used, transmitted, and processed for the purpose of measurement. In textbooks today, sensor and transducer are being used with the same meaning, but there is a difference between sensor and a transducer. So, in today's textbooks, if they are using this term, they mean it as a transducer, they mean it as a sensor, and if I are using the term electrical transducer, they mean it as a transducer. Now, these transducers can be classified based on some principles. Let us suppose if I take some classification criteria. First, the criteria can be based on the transduction principle. Based on the transduction principle, transducers can be classified as resistive, inductive, and capacitive. That is, the physical quantity we want to measure, if it is converted into resistance form, then it is a resistive transducer as a sensor. Inductive form, inductive transducer. Capacitive form, capacitive transducer. So let us take an example of a potentiometer or a strain gauge. It is a resistive transducer. A LVDT is an inductive transducer. A microphone is a capacitive transducer. The other classification is analog and digital transducers. Analog transducers will give you output in analog form, whereas digital transducers will give us output in digital form, that is in form of pulses. The other classification goes is primary and secondary. Sometimes one transducer might not be enough to convert one physical quantity into another form. So we may use two transducers for that thing. So the first transducer is called a primary one, the second one is called secondary one. If we use the third one, we can mention it as tertiary. And finally, transducers and inverse transducers. Many don't agree with this classification, but if we are defining a transducer as a device which converts one form of energy into electrical form, then the device which converts electrical form into other form of energy like mechanical, optical, chemical, then that device is called a inverse transducer. Now, very important term, that is error. When we are using an instrument or a measurement system to measure some physical quantity, then error comes into picture. So error is defined as the difference between measured value and true value of an instrument. Let us suppose I am measuring temperature using a thermometer. The actual value is 35 degrees centigrade. The measured value is 35.2 degrees centigrade. So that zero point 0.2 is the error. So this error has to be minimized. So generally we have types of errors in measurement. So we can classify errors as random errors, systematic errors and gross errors. So generally when we are talking about gross errors, sometimes we take a reading. If the reading is 25, maybe we write it as 26. So such type of errors come under gross errors. Next errors are systematic errors. These errors are classified into three types: observational errors, environmental errors, parallax errors. So observational errors, example, uh, parallax error. When we are using a deflection magnetometer, the parallax error is called a observational error. So next one is environmental errors. Due to environmental quantities, we some errors creep into the instrument readings. These are environmental errors. Next are instrumental errors. These instrumental errors again are classified into three types. There are maybe because of the inherent limitation of the devices. Next, it can be because of the abuse of apparatus, and third, it can be because of loading effect. Because we all know that the external device connected to the sensor or transducer acts as a load. When it acts as a load, what happens is, due to this loading effect, the displayed quantity will be less than the actual quantity. This loading effect has to be minimized. Okay, so these are systematic errors. And coming to random errors, so other errors which doesn't fall into this category are called random errors. So these are the classification of errors. So this is an introduction to the basic terms related to uh, measurement systems.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.